We have a test coming up at the end of this week and the beginning of next week, so this is one of a couple of videos that helps us prepare and get ready for the test and review some of the stuff, especially since it's been so spread out. Okay, so as we're looking at these two graphs, these are not logs now, these are exponential functions, and we want to compare f of x compared to g of x. Now before you even put this in your calculator, we know what some of these things are. Over here where it adds 3 with the x, that's going to shift it left and right, and it's the opposite of what we think. So we know that compared to f of x, g of x is going to be moved left 3, and the minus 4 is going to tell us down 4. Okay, now we need to put these into our calculator so we can graph them. So we're going to come over here to the y equals. We're going to clear out what's in here. And over here, we're going to put 2, and then you're going to use this caret button and do the x. That's the first one. And now we have to do the second one. So we're going to do 2 caret, and then up here we're going to have x plus 3. Now the minus 4 is out of the exponent, so we have to do minus 4. So you have to arrow to the right and then do minus. Make sure you do a minus and not the plus or the negative sign. Do minus 4. We can take a look at that graph. So here's our original one. As we move from left to right, it goes up, so it's exponential growth, and we knew that because 2 is greater than 1. And then here's the next one that shifted down and moved to the left, so that makes total sense. So the way we graph these is we got some points off of the table. And since these are a little more easier to get specific points, so I want you to get 4 or 5 points. So if we go to our table, here we go. So we can start putting some of those in. So I'm going to graph the point -1, 1/2, 0, 1, 1, 2, so forth and so on. Put that on my graph. So I'm going to do the f of x in blue. And these points I'm just reading right off the table. And I'm just not flipping back and forth, not trying to make you get dizzy in the video. Okay, now we're going to do the same thing with the second graph. But this time when I read it, I have to read what's written in red over here. So I have -3, -3, -2, -2. Let's look at some of these. -3, -3. If you wanted to, you could do -4, -3.5, -2, -2, -1, 0. Let's try and get one more. 0, 4, and then it goes up to 12, so that's a little high. 0, 4, so then we can draw this graph, and this is going to approach -4. Now, notice that these graphs, unlike the log, have a horizontal asymptote. So the blue one is approaching 0, and the red one is approaching -4. So it's on the y, not on the x, like it was with the logs. So for the domain is the x values. We go left to right. Well, to the left, out here, has all of these values, and to the right, even though it's going up, it's still moving over to the right, so we have all of these values. So our domain is -infinity to infinity. The range, we go from bottom up. Now remember, we're reading this from g of x, which is the second graph here. So for the range, going from the bottom up, it starts right here at -4. Now it doesn't actually touch -4, it's an asymptote, so I have a parentheses, and it continues up, so I have infinity. Also notice at the end, there is a -4. That's not a coincidence. The y-intercept is when x equals 0. So I'm going to look at my table, and x equals 0 when y is 4. So my y-intercept is 0, 4. Okay, let's try this again with these two graphs. So again, I'll graph the first one in blue and the second one in red, but before I even graph it, I can figure out what the shifts are. This one adds 3, so it's going to go up 3. So now let's see if we can graph it. So I'm going to go to my calculator. I'm going to go to the y equals. I'm going to clear out anything that's in there. Okay, and when I do that, now I'm going to put the new ones. So I'm going to do alpha y equals option 1, and this gives me 1/2. Then I'm going to arrow to the right so I can get out of the fraction and then do the caret and the x. Go down to the second one. Alpha y equals option 1. I do the 1/2, arrow to the right to get out of the fraction, the caret and then the x. Now that plus 3 is not in the exponent, so I have to arrow to the right to get out of the exponent and then do plus 3. So now I can see my graph. Now this one, the 1/2, is between 0 and 1. So this is exponential decay and not growth. So there's our original one, and here is the second one. And just as we predicted, it is shifted up. Okay, so now we can go to the table and we can see our points. Okay, so as I graph them, -416 doesn't work, but -3,8 does. So I can have -3,8, -2,4, -1,2, 0, 1, 1, 1/2. This going down this way, and this I meant to be blue, but we'll just recolor code that to green. Okay, now we're going to do it again, but this time with a second graph. So now I'm looking in the second column. Well, -311 doesn't work, but -27 and -1,5 work. And then we have 0, 4, and then we get 1 7/2. Well, 6/2 is 3, so 7/2 has to be a little above 3, so it's going to be in here. Whoops, that was not a very straight line. Try that again. Look like this. So it's approaching this line here at 3, but it's not actually touching that line. So the domain of my g of x, which is the one in red, okay, the domain left to right, I can plug in whatever I want for x. So the domain is going to be all real numbers. The range goes from the bottom up, so I'm working my way up. I've got nothing until I'm here at 3, so it starts at 3 and continues up, but I put a parentheses because it doesn't actually touch 3, it just gets really close to it. And notice, +3, 3, not a coincidence. The y-intercept is when x equals 0. So if I look at my table, when y equals 0, it's 4. Now, it just so happened that both of these are 4, but that is definitely not always the case. All right, so the second part of the review, we're reviewing this interest stuff, and I do have the equations written out, so I'm just going to talk through this. Just like on your quiz, on the test, I'll give you the formulas, but you need to know what to put into them. So this P stands for A is what you get when you're all done. P is the initial value. R is the rate, that's normally the percent. N is the number of times that it's compounded. Okay, and then T is the time. Now, how do we know when to use which formula? Well, we use the one with E anytime it says the word continuously. So on this first one, I did 4,600 times 1 plus the rate is a decimal. I got to move the decimal over 2 places, 0.035. It's compounded monthly, which is 12, and then 12 times 15 in the exponent. So if I want to put this into my calculator, I would do it like so. To get out of the table, you do second quit, and then I'm going to do 4,600, parentheses, 1 plus, and then my fraction would be alpha y equals, my rate is 0.035, it was monthly, so that was 12, arrow to the right to close my parentheses, caret to get my exponents, and it's 12 times the years, which is 15. I hit enter, and here's my value. I don't tell you what to round to, but it's money, so you have to round to 2 decimal places. So my answer would be 7,770.17. Oops, I rounded 7. There we go. Okay, on the next one, everything is the same. The initial value is 4,600, 1 plus the rate, but this time it's compounded quarterly. Quarterly is 4 times a year, so then we have 4 times 15 up in the top. Now, if I go back to my calculator, this equation is almost right. If I want to recopy it, I do second and then enter, and I get the equation back. Then I can arrow to the right. I'm going to go over to, oops, I went over too far. I'm going to go over to the 1 and I'm going to type 4. Well, right now it says 42. That's not what we want. I want that 2 gone. So with my cursor flashing on the 2, I'm going to hit the delete button, and then it goes away. And I'm going to do the same thing on the others 12. Put my cursor on the 1 and make it a 4. Go to the 2 and hit delete. And there's my equation, and I can hit enter. So you make a little bit less because it's not compounded as much. So you have 775837. Okay, but on the last one, we knew it was compounded continuously, so we knew we need to use our other formula. So we're at 4,600 as our principal. E, rate is still the 0.035, and the time is still 15. But when we put that in our calculator, we have 4,600 times E is right above the natural log, so second natural log, and then we have a rate 0.035 times time, which is 15, so we get our answer 7776.11. Okay. These problems, we're trying to figure out if it's growth or decay and write the equation without doing anything fancy in your calculator. So how would I go about doing this? Well, as I'm looking at these values, at time 0 it's at 8, and at the end it's at 19. So it's going up, so I know it's growth. To find the factor, I'm going to do 9.6 divided by 8. And when I do that, I get 1.2. So that is my growth factor. The initial value is what it's at time 0. And at time 0, it's at 8. So my equation is going to be y equals 8 times 1.2 to the x. That's it. Now, this works if you're given what it is at time 0. This chart gives you what it is at time 0, so you could do the same thing. However, you're going to get some data that doesn't start at time 0, and when it doesn't start at time 0, you need to use regression testing in your calculator. So how do we do that? Well, you're going to go to your calculator, you're going to go to your stat menu. The first thing we need to do is enter the information, so we're going to hit edit. If there's information there you don't need, you're going to hit clear and down arrow, and then it'll clear everything out. But I already have the numbers in there, so you can put the numbers in for yourself as well. Once you have all the numbers in, you've checked they're correct, you're going to hit the stat button. Now we need to do a calculation, so we're going to arrow to the right, and this time we want to do exponential regression. So we need to go up and choose choice 0 and hit enter. So our x's are in list 1, our y's are in list 2, and then we're going to ask the calculator to calculate. It'll say this on your test. It doesn't on your worksheet, so I apologize, but we're rounding to the nearest hundred, so 29.98. So A is, I need a pen on it, 29.98, which is really close to 30, isn't it? So it's accurate. Our B, which is our growth or decay factor, is 1.9. Okay, so when we write our equation, it's going to be 29.98 times 1.9 raised to the x. X is our time. So in this last question, it asks us what it is after 6 years. Well, our chart doesn't go to 6, but we can put 6 in for x and we can solve. So we can do 29.98 times 1.9 to the 6. So we can do 29.98 times 1.9 raised, I have 19. That's not going to be the same. 1.9 raised to the 6th power, and hit enter. Now, this chart here is talking about the elk population. And when we're counting elks, we're only counting whole elks. So that's going to be 1,410 elks. We'll cut that off. So we're going to say 1,410 elk. And that's our answer. We'll do more review next class so that you're prepared for the test.